Hi, everybody. Today on the Data Show, we're going to talk about if you have high blood pressure while you're sleeping, masked asleep hypertension. Today on the Data Show. This is the Data Show. Your host, Chris Greco, me, here for your February installment of the Data Show. Hope you all had a very, very nice holiday season between December, January. I know that the cold has somehow gripped the entire United States. So, those of you that have dug out, I hope that you're taking the time to sit down and just enjoy the show. And if this is your first time here, understand the Data Show is about studies. What we do is we try to analyze studies, try to figure out the validity, the veracity of the study, how it all shapes within our daily lives. And February, since it is Heart Health Month, I figured that we would throw in a heart study. And when we talk about cardiovascular disease, we talk about different heart areas. We can't help but address hypertension because hypertension is probably, and this is through studies, is probably the main cause for heart ailments, whether it be heart disease, whether it be stroke, and it can be correlated with different types of maladies such as diabetes. But obesity seems to be a major portion of heart disease, heart hypertension, those types of areas. But today we're going to talk about is masked asleep hypertension. And there was a study that was talking about masked asleep hypertension. We're going to discuss that study today and go through that and try to figure this thing out from the standpoint of where it is and the study and the veracity using different measures and try to score this thing at the end to try to find out if it is in fact a good study. There are no really bad studies per se, but what happens is that the media really blows this all out of proportion. And then the media brings in their experts, these MDs, these doctors, that discuss it like, they have somehow been a part of the study and they haven't. And I think what they try to do is bring up a lot of common sense approach, like lose weight, exercise, those types of things. And if you go through it in the media, that's what they talk about is exercise, eat right, try to get as much sleep, those types of things. So masked asleep hypertension, that's going to be our deal today. So all the information was from the study. JAMA, JAMA is the Journal of American Medical Association, and cardiol means it's cardiology. So it's specifically a cardiological study. And this is the study we're going to be taking it from. You can also get it at this area here. I usually go to PubMed, which is done by the National Institutes of Health, and it's a government website, and it throws out a lot of these studies, and it's really neat to be able to look at government websites because they do a great job of culling. I guess culling is word is collecting these studies and making sure that they put them in the right categories, which is kind of nice. So what we're going to do is we're going to do a data analysis of this study specifically, the one from the Journal of American Medical Association. We start with a hypothesis. Now, just to review one more time, what is a hypothesis? So the hypothesis is a statement, but interestingly enough, is it's a statement that comes from a question. They call it a research statement. There's a lot of other things that we talk about, but hypothesis is basically a question that's been turned into that's been turned into a statement. So that's what we talk about. We talk about hypothesis. So if we're going to talk about hypothesis, we talk about something like does smoking cause cancer? Okay, that's a question, and it's a question that you can bring up, right? You can take a look at, does smoking cause cancer? Now, you change that to a hypothesis or a research statement by changing that into a statement. So basically, it goes like this: smoking causes cancer. Now, that then turns out to be your hypothesis. So it what it does is it sits back and says, okay, smoking causes cancer. Does smoking cause cancer? Smoking causes cancer. So you're making that as a hypothesis and you're putting that out there and you're trying to figure out exactly what goes on. So, what is the hypothesis from this? Um, well, this is a statement from the study. To estimate the prevalence of master sleep hypertension among U.S. adults by using BP blood pressure thresholds from the seventh report of the Joint National Committee on Prevention, Detection, Evaluation, and Treatment of High Blood Pressure. JNC7 is what's called, and the 2017 American College of Cardiology, American Heart Association, ACC/ACH BP blood pressure guideline. Where is the hypothesis there? To estimate the prevalence of masked sleep hypertension. So there's really no hypothesis per se. It's mainly like a count. They just want to estimate how many masked sleep hypertension people there are. And so that unto itself is kind of, what's the reason for the study to count up the number of blood pressure, high blood pressure while you're asleep type aspects. So that to me is not really a hypothesis per se. It's kind of an informational study. It doesn't present any correlation or causation, anything like that. It just says, should we? I guess the bottom line is, should we be concerned? So I'm not sure if that's really. I mean, it's a study, I guess, if you really want to say it, but what really does it show? That So that'll come up later. Sampling method. The next area we're going to talk about is sampling. Now, sampling and random sampling. Random sampling, everyone talks about, oh, this is a random sample. No, not really. Random sample is you have an equal chance of selection from the entire population. In other words, the entire number of people that you have out there, right? And when you do that, you sit back and say, every object has an equal chance of being selected. So, all right, how is that? If there's an equal chance, there's an equal chance. If there's not, is not. The sampling method in this study was what they call a cohort analysis. And it's pulled data from 3,000 participants in 4 U.S. population-based studies. And let's talk about these definitions here for a second. 24-hour ambulatory BP monitoring. Ambulatory BP monitoring. So what's ambulatory BP monitoring? It means people are sitting there, they're getting, they're getting their blood pressure taken. There's little, if no information on when their blood pressure was taken, what day it was taken, if it was taken every day. It says 24-hour ambulatory BP. So I'm not sure if it's a 124-hour BP ambulatory monitoring. Did they just have a blood pressure cuff on them or a blood pressure monitor on them for 24 hours? Not much in the study itself to talk about that. The documentation that I saw. So I'm just not sure about that. But they said there's also 17,969 participants in the 2011 to 2016 National Health and Nutrition Examination Survey without ambulatory BP monitoring. So you have 3,000 participants in 4 U.S. population-based studies for 24-hour ambulatory BP monitoring. So it's day and night. And I'm assuming that they just had this thing on them for 24 hours. And the other one was a nutritional survey without ambulatory BP. So mass sleep hypertension status in NHANES was imputed using a 2-stage multiple imputation process. So that's interesting. We'll go into that a little bit later. Data was collected from 2000 to 2016 and analyzed from March 2019 to June 29th, 2020. So it's interesting that they said it was collected from 2000 to 2016 when the participants in the NHANES study was 2011 to 2016. So that unto itself is interesting that they would state that. But the imputation process, we'll get into that. We'll get into that. Well, let me get into that right now. So basically, imputation process is this. You have missing data. The imputation is trying to determine from a reasonable process what that data was. Now, there's several ways of doing that, but the imputation process is something that tries to fill missing data with data. So right there, it's yes, there's probabilities, and yes, they try to impute it with a probability and with a reasonable probability of all that. But the bottom line is this: is that they are putting in data where data does not exist. So missing data is missing data to me. To try to put in data where you think data should be is not manipulating the data per se, but it might be a way. I don't know how they're going to mess with the testing. So it may mess with the statistical test, and we'll go into that a little bit later. This is the NHANES website, and I have it here below. So if you want to take a look at it, you can. And this is the questionnaires, data set, related documentation, all these things. But understand that no matter what you do, survey is what they call self-reporting. Self-reporting in and of itself creates a bias. We'll talk about some biases later on. But that bias means that I'm going to put in the data that I see in front of me, maybe, but if I have a blood pressure that I don't think is reasonable, I may wait and take it again, or I may take it until it's within normal range, or, in other words, I may not be reporting the true value of that blood pressure monitoring, but no one knows any difference, right? And also, you're self-reporting things like demographics, which could be an issue again, because it all depends what you think you are, in the way of demographics as to how you're reporting that, which means now you're put into a category where you may not belong. So self-reporting is a definite issue, and it's unquestionably one of the main biases in any survey that you do. And you put that in the limitations of the study, which is good, but that is a major issue. Now let's talk about data definitions for a second here. Data definitions means that you try to have consistent data definitions. And here's why you need consistent data definitions, is because if you don't have consistent data definitions, then you're not going to have consistent results. Your statistical tests are not going to be able to do the things you need to do because you don't have good, solid, consistent, reliable data definitions. How did this study do with data definitions? Well, here's what they said. Data definitions, I think, in this case, was excellent. High clinic blood pressure was defined as clinic systolic blood pressure, STP, diastolic blood pressure, DDP, of at least 140/90 using JNC7, which is what we had in the beginning, and at least 130/80 using 2017 ACA, American College of Cardiologists, American Heart Association guidelines. High asleep blood pressure was defined as mean asleep, STP, systolic, diastolic. So systolic is the above number, and diastolic is the below number, right? Of at least 120/70 for JNC7, at least 116, 110/65 for the 2017 ACCACA. Now, what is normal, right? So normal is 120/80, supposedly, although they're kind of messing with that a little bit from the standpoint, but let's just call it 120/80. If 120/80 is normal, your 110/65 is considered to be great if you were awake. If you're asleep, you have a problem, because now you have high, mean asleep, so defined as high asleep was defined as mean asleep, mean average asleep pressure of 120/70 and at least 110/65. Massive sleep hypertension was defined as high asleep blood pressure without high clinic blood pressure. High clinic is defined as basically those guidelines you saw here, 140/90, 130/80, right? High sleep blood pressure without high clinic blood pressure. So that's an interesting. Uh, I thought that was, I mean, and if they were consistent with that measurement, if they were consistent, I don't like the at least thing because now you got at least. So it's like, all right. So anything above that, you're gonna. But at least they, at least, at least they did what they needed to do to set that minimum, which is good. That's a good thing. I think the data definitions I think are excellent here because they really set a good consistent, as long as they followed it, good consistent aspect. With that imputation thing really bothers me, but hey, you got to do what you got to do. Next area we're going to talk about is statistical tests. Statistical tests can range from just simple, averaging to standard deviation to Spearman correlation, chi-square, statistical tests. And it all depends what type of statistical test you have. Well, in this case, what they did was it was very straightforward. Mean standard deviation. That's what they did. Now understand, and this is a refresher. Mean is a non-robust measure of central tendency. It's highly influenced by high and low values. So, and standard deviation is dependent upon the mean for its calculation. So if you have a mean that's very off, standard deviation is going to follow suit. And the mean measures central tendency, and standard deviation measures the variation within that data. So other than that, there's no more complicated statistical tests were completed other than the imputation aspects, which is not a statistical test. It's attempting to fill in missing data. Was it parametric or non-parametric? Well, parametric means that you think that a test, you think that the data is along a standard normal curve. So that a mean and standard deviation usually translate to a parametric curve or a standard curve, because that's exactly what a standard curve is. Mean standard deviation. That's what it is. So it's parametric. They've used parametric testing for that. Robust or non-robust? Well, they didn't use a median, which would have been more robust. They use a not robust type of measurement, which can be a problem when you have very high values, very low values. It pulls that average, either way, and that means it's not robust. Were there any biases that were part of that, or confounding factors that were put into that? Well, the confounding factors are, you can list a ton of confounding factors. For instance, what was their sleep time? What was their awake time? Did they know that they were being tested? Well, if you're asleep and you're wearing a monitor, you're being tested. That in itself puts a bias into the system. And the main confounding factor I saw was the method of obtaining the blood pressure. So if they were asleep, they must have known somewhere along the line they were having their blood pressure taken. Now, it could have been from a wrist monitor that didn't bother them. But if they were having it done by a monitor, by a blood pressure cuff, then that means that they had to be awakened to take the blood pressure, which means they know that they were being tested. And also, you wake me up in the middle of the night, my blood pressure is going to go up. So I don't know how that was done, and that was not explained in the study itself. So I'm not sure how that was done. Now the main bias here is called the Hawthorne bias. And where did I get that? Where did I get the bias? Well, there's a catalog of bias. Believe it or not, I put the website there at the bottom. You can take a look at it. But that Hawthorne bias was done. It's a really old what they call the Hawthorne experiment. Hawthorne, Illinois. They messed with the lights while the assembly plant was going in a Hawthorne, Illinois plant, and saw what the reaction was. Well, the people knew that they were messing with the lights, and it showed the productivity when they dimmed the lights, productivity went up. When they heightened the lights, productivity went up because people knew that they were being studied. So they call that the Hawthorne bias, the Hawthorne aspect. So that it definitely, if people know they're being tested, the Hawthorne bias automatically exists. The same way that they try to study nature, and they put these fake rocks out there, or fake igloos, or fake pieces of ice, or whatever it is, with cameras in it, and they try to test polar bears, and the polar bears go right to the camera because they see there's something different in the environment. So all of a sudden, the bear knows that they're being something's up, and it completely skews the whole idea behind experiment and non-observation, hidden observation. What type of limitations were there? Biases usually are placed in limitations category in the data study, but these limitations are it's the one of the limitations is um, it's the study list. One limitation of study is being the results of taking blood pressure, but there needs to be more study of addressing the treatment of high blood pressure while asleep. So, in other words, what they were doing was trying to figure out in the beginning the prevalence of masked asleep hypertension. They found the results were that there was, millions of people with uh, massive sleep hypertension, which means that this is hypertension that you're not aware of. So, how do you treat it? How do you treat people when they're asleep having hypertension? I don't know. I take a blood pressure medication at night. I take a blood pressure medication during the day. So it's that type of thing. But am I really treating the massive sleep hypertension? Only if you're wearing a monitor that accurately measures blood pressure at night. Otherwise, you're going to be waking yourself up, every 2 hours, 4 hours to take a blood pressure. So that seems to be a problem. So, but the study did explain that limitation, and I think that was well done. So let's go through a summary here real quick. The hypothesis. Was there a hypothesis? Well, really, it's not applicable. There was no real hypothesis. Like, does mass sleep hypertension inflame cardiovascular disease? It wasn't like that. It was just literally a number system trying to count up how many people had this massive sleep hypertension. Hypothesis wasn't applicable. There's no hypothesis that I could see. Sampling was excellent. I mean, thousands and thousands of people. Now, we'll get into the biases later on. Was it random sampling? No. Was systematic sampling? No. It was basically 3,000 people done. I don't know how they did that. There was no sample methodology, and also the NHANES is a survey, so it's self-reporting, so that could be an issue. Statistical tests average. It's the average, kind of ironic because that's what they used, right? The mean and the standard deviation. Rather than median would have been a more robust measure of central tendency, which would have been good. And people say, yeah, but there's no measure of variation with median. Yes, there is. It's called a median absolute deviation, which you could use to make up a curve that shows the median as a center and the variation being the median absolute deviation. So you could do that with median, which is more robust. And the confidence intervals, they were wide, about 8 to 9% in some instances with the 20% aspect. So 8 to 9% could mean a lot. That's a pretty wide spread on confidence intervals. And the confounding factors, again, average. No mention of how the blood pressures were obtained. This could be an indication of inconsistent measures, right? Or the subject being aware of the measurement, which again would throw in the Hawthorne bias, which would be it. This is just a pretty subjective score here. So 1 to 30, based on the 4 categories, you have hypothesis, which is 5, sampling, which is 9 out of 10, statistical test 5 out of 10 because there really weren't any except mean and standard deviation, and confounding factors, and these are negative points. And that's basically -5 because we're talking about the Hawthorne bias, as well as just strictly, the idea that Hawthorne bias is a big bias because you are affecting you're affecting those areas when it comes down to the actual measures, right? If I know I'm being measured, There's going to be a distinct difference as if I don't know I'm being measured. So total score about 14. Does that make it a bad study? No. I think that basically what happens is that this throws it into the idea that studies are done within limitations. They have limitations on every survey that you can ever do. Um, there's self-reporting. Self-reporting brings in a bias, and that can be an issue. So those types of things have to be taken into consideration. So I think the 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 idea behind this whole study was trying to figure out, is there something that needs more study? Most studies go that direction. Um, when you do something like that, you bring in the idea that the study needs more study, which is probably a case in most instances when we talk about that. So that's my study for today. I talked about the hypertension aspect, mass sleep hypertension. Of course, the media went nuts about it. They you really cannot take what the media says at face value. You're going to have to go out and find the study for yourself and look at it and see exactly what you think, because this is all my opinion. This is totally my opinion on the data show. If you have any questions, or you have something you have study you want me to take a look at, or you think that there might be something up, you don't have the basics to be able to go after it, I will certainly discuss that on the show. I have the site below, but I additionally have I have a email, and you can certainly, you know, there's my email right there. Please email me. I'd be more than happy to do that and talk about the study and split it up into these different category aspects, and then score it at the end and see what you think. You may have a different scoring, which is fine. Again, this is all my opinion. So that's pretty much it for the data show for February. So appreciate it very much. Again, if there's any studies you want me to do, please let me know. You can email me, and be more than happy to take a look at it for you. This is Chris Greco signing off for another data show. And please, always, please check the data and take care. And whatever you do, have a great February. And please be safe out there with all that ice and snow, and also when you're shoveling or doing anything else, because it is Heart Aware Month, right? So be careful. Be nice to your heart.